In the introduction to calculus video, we talked about differentiation, and we said that differentiation was the rate of change of a function or the gradient of a function. So we showed the function y equal x, where the function y equal x looks something like this. So our f of x is equal to x. And we proved that the derivative of this was 1 by finding the gradient of this function here. We use the principle that this point on the graph, if it was 2, then this point here would also be 2. And if we came halfway down, and this point was 1, right here, then this point that corresponds to it here would also be 1. So the change in y over change in x would be 2 minus 1 over 2 minus 1, which would be equal to 1 over 1, which is 1. So this is what we did in the intro to calculus video. So let's take a more detailed look at why the derivative of x is equal to 1 using what is called first principle. So first principles is a series of steps that we take to prove our derivatives. So the first step in first principles is to identify our function. After we identify our function, we add a small change in x to that function. Some books use h, but we will use delta x. So f of x plus delta x. This delta x is a small change in x. Step 3, what we do, we subtract f of x from this function and divide by the small change in x. So f of x plus delta x, we subtract f of x from that and divide by delta x. For our last stage, we find the limit of this function in step 3. So the limit of f of x, whatever value you get here, f of x plus delta x minus f of x over delta x as delta x approaches 0. Whatever value you get from this step is your derivative. So let's do that with x. Remember, we know that the derivative of x is 1 from the past video and from what we did above in the show using the gradient. So our first step, identify a function which is x. Our next step is to add a small change to x. So f of x plus delta x would be equal to x plus delta x. For our third step, we subtract f of x from this and divide by delta x. So we'd have our f of x plus delta x minus our f of x, and we divide this by delta x. So we'd have x plus delta x minus x divided by delta x. Here, the x cancels because this is a positive x, this is a negative x. So they subtract. So we're left with delta x over delta x. For our final step, remember, we find the limit of whatever we got here, and delta x over delta x would be 1, right? And the reason for this is because if you have 100 over 100, you get a 1. If you have 10 over 10, you get a 1. Whatever value you have over that value, you get a 1. So from the same principle, delta x over delta x is equal to 1. So in our fourth step, we find the limit of 1, which is what we got from our third step, as delta x approaches 0. From limits theorem, we know that when we find the limit of a constant, then the limit is equal to that said constant. So here we have proven that our derivative of x is equal to 1. If you remember from the introduction to calculus, if we have a function y equal k, where k is a constant, then the derivative of that constant would be 0. And we're going to use first principle again to prove that. Our first step is to identify our function. So our function f of x is equal to k. Our second step is to add a small change to x. At this stage, if we look in our function, we have a k. We don't have a x inside that function, so we can't add a small change of x to the function. So at this stage, we will still have a k. Our next step is to subtract f of x from what we have here and divide that by the small change in x. So we're going to have f of x plus delta x minus f of x. All of this is over delta x. This stage we have k for this portion, and this portion is also k. So k minus k over delta x. Whatever value k is, when we subtract that, we'll have 0 over delta x. And 0 over delta x is equal to 0. Our next step is to find the limit of whatever we got in our third step as delta x approaches 0. So let's do that. So we're going to find the limit of 0 as delta x approaches 0. Again, 0 is a constant. So when we find the limit of the constant, we get the constant. So the limit of 0 as delta x approaches 0 is equal to 0. And here again we have proven that the limit of a constant is equal to 0. Let's put a value to our constant. Say our function y was 7. Using first principle, we identify our function. So f of x, remember f of x and y is the same thing. So f of x is equal to 7. Our next step is to add the small change. But there's no x to add the small change to, so it would still be 7. So f of x plus delta x would still be 7. Our next step is to subtract f of x from this and divide that by delta x. So f of x plus delta x minus f of x over delta x is equal to 7, which is this portion, minus f of x, which is also 7, over small change in x. This would result to 0 over delta x. And this would be equal to 0. In our final step, when we find the limit of this 0 as delta x approaches 0, we get 0. So we see that it doesn't matter what constant we have, we will always get a 0. On the left, we can see our derivatives. And as we see again, the derivative of x is equal to 1. And you can study the derivative table, learn them so you don't have to always do first principles. And you will learn other principles and rules that makes this a lot easier. So pause the video where you want to look at the derivative. There are 14 of them, and study them. Okay, so this is it for this video. Thank you guys for watching.